Welcome to basic integration by substitution. So the general idea here is recall from the chain rule. So recall the chain rule, which says that the derivative of a composition of functions, f of g of x, is f prime evaluated at g of x times g prime of x. Thus, we can take the equivalent in integration. So the equivalent statement in integration the equivalent statement with integrals is the integral of f prime of g of x times g prime of x dx is equal to f of g of x dx. Sorry, f of g of x plus c. So for example, let's go ahead and evaluate the indefinite integral of 3x squared times cosine of, in parentheses, x cubed plus 2 and parentheses dx. So note this cosine of x cubed plus 2, we have a function composition. And if we have a composition of functions, this tells us that we may be able to force this sort of chain rule form. So we can kind of force a chain rule, try to force a chain rule derivative. So what we need essentially is we want 3x squared times cosine of x cubed plus 2 to be equal to f prime of g of x times a g prime of x. So what we want is we want the inside function from our composition to then have its derivative be what's on the outside essentially. So our g of x here would have to be that x cubed plus 2. And so our g prime of x does in fact equal 3x squared, which is exactly what we would want. And then what we have essentially is our f prime of x would be the outside function cosine of x. So essentially what we have is we have the integral of 3x squared cosine of x cubed plus 2 dx is the integral of the derivative of, we have f prime of x equaling cosine x would come from f of x being sine of x. So it's going to be the derivative of sine of x cubed plus 2. And then dx. So essentially what we did is we took I essentially undid the chain rule, right? So the chain rule, we had cosine of x cubed plus 2 times 3x squared. X cubed plus 2 was my g of x. 3x squared, fortunately, was my g prime of x. And then f prime of x has to be cosine x. That goes straight back to sine. If f prime is cosine, f will be sine or sine plus c, sine x plus c. And so we wind up getting then that this integral is simply equal to sine of x cubed plus 2 plus c. Now, I find it confusing to use f of x's and g of x's and leave it all in x's. So a standard process is to use what is called U substitution, where we essentially change variable. So an alternative way of writing the chain rule is to use U for the inside function and so that chain rule becomes the derivative of f of u with respect to x is equal to f prime of u times du dx. So the equivalent in integration would be that the integral of f prime of u times du dx is equal to f of u plus c. So note that when it comes to differentials, du is by definition du dx times dx. And so what we can do is we can rewrite our integral entirely in use. So we have the integral of f prime of u du dx times dx. This is equivalent to the integral of f prime of u du. At this point, we can just integrate with respect to u. And then switch back to x after the integration. So if we take a look at that example we already were working on, if we wanted to do the integral of 3x squared cosine of x cubed plus 2 dx, the inside function is x cubed plus 2. And so we will go ahead and set u equal to x cubed plus 2. Then we have du is du dx, derivative of u with respect to x, times dx, which would just be 3x squared times dx. Then our integral of 3x squared cosine of x cubed plus 2 dx is just the integral of cosine of x cubed plus 2 times 3x squared dx. We can go ahead and swap out x cubed plus 2 for u. That 3x squared dx is our du. So we are now looking at the integral of cosine of u du. That's an integral we do know. Integral of cosine of u is simply sine of u plus c. And now we'll go ahead and plug in u equals x cubed plus 2. And so we get right back to what we previously found with sine of x cubed plus 2 and then plus c. Personally, I find this much easier to follow than trying to follow the chain rule with f of x's and g of x's for doing our integration. Hence why we do substitution. We essentially make it so that we don't have to keep track of everything all in one step and can revert to a simpler variable for our integration. So that's an intro to u substitution. We'll look at more examples in the next videos.